Yo, what's up? We're back at it. Today we're gonna be doing Chem Quest 6. Let's get on with it. Okay, so Chem Quest 6, it's about like specific heat, depend on state of matters. So it says recall that specific heat is the energy necessary to raise the temperature 1 gram of a substance by 1 degree Celsius, 1 gram by 1 degree. Specific heat of liquid is a constant equal to 4.18 joules per gram. Um, this means that it takes 4.18 joules to raise the degree by 1 degree Celsius. Um, for ice, it's going to be 2.06. For steam, it's 2.02. You want to remember these three types of specific heat for H2O. So we're going to be using these types of values. Okay. Number one, how much energy is required to heat 32.5 grams of water from 34 to 75 degrees Celsius? So on a test, you're given this question, right? You don't know what to do. This is how you know which formula to use. So you see grams and you see Celsius. You see a change in degrees Celsius. You recall that the formula that has both mass and temperature is Q equals MC delta T, right? M is the mass, T is the temperature change. So when it says from 34 to 75 degrees Celsius, it raised from 34 to 75. And so we're just going to subtract to find the temperature change. So 75 minus 34, this is going to equal 41 degrees Celsius. And then that's our temperature change. Our mass is 32.5. And then our C, because you don't have our C value, C is specific heat. And specific heat of water right here is 4.18. Oops. So we just plug and chug because, right, we need to find energy. So we need to find Q. Q is energy. So Q equals, right, 32.5. The C is 4.18. And then the change in temperature is going to be 41 degrees Celsius. Oh. So you do all this, right? You should get 55,569.9 kilojoules. Oh, yeah. All right, next one. How many joules of energy are needed to heat 45 grams of steam from 130 degrees Celsius to 245? Why don't you use 4.18 joules over the grams degrees Celsius in this calculation? So there's two questions in here. Let's focus on the first one, right? How much joules of energy, right? So when it's asking for joules of energy, we automatically know, oh, we need to find Q. So we need to find Q. Need to find Q. And then I need to heat 45 grams, right? Grams is just mass. And then we have a temperature change from 130 to 245. So it went from 130 to 245, it raised. So what's the temperature change here? And so when we see both mass and a temperature change, and we see that we need to find energy, we automatically know that's going to be Q equals MC delta T. Because Q equals MC delta T, right? It is both mass, temperature, and energy. It is everything we need. Okay, so right now we need to find the temperature change. 245 minus 130. 511. So plugging everything in, we need to find Q, right? So Q equals the mass is going to be 45 grams. We'll get back to C in a bit. But temperature change is going to be 115. And then our C value, right? In the previous question, we used 4.18. And this is because it asked for water. Oops. right? We know that water is the constant temperature for water is 4.18. But in this question, it asks for steam. Do you see that? So steam specific heat is 2.02. So we have to use 2.02. So plugging everything in, Q will equal to 10,453 kilojoules. And now for the second question, why don't I use 4.18 in this calculation? Well, I just answered it, right? Like it's asking for steam. They want you to find steam. Steam's specific heat is different from water's, right? Steam's specific heat is 2.02, while water's is 4.18. So we can say that the reason why we have to use 4.18 is because we're dealing with steam. So we don't use 4.18 because we're dealing with steam. Four point one eight deals with water. Okay. Here we go. So next question then. Why is it impossible for you to answer the following question right now? How much energy is required to heat 35 degrees? 35 grams of H2O to 25 degrees Celsius to 150. So this question is kind of odd. Like if you did watch the video lecture, then you should be able to answer this. But like the only reason why is because like, well, like if you look up the answer, which I did, I'm not gonna lie with you, I did look up the answer. It just says that like we haven't learned it. Like literally, it just says we haven't learned like phase changes and those type of stuff. So you don't even need to know this question. Um, uh, yeah. So yeah, the answer that you can look you guys can look it up, but it doesn't make any sense. So we can just skip this one because the answer says the answer literally just says because we haven't learned like phase changes, how to calculate phase changes. But if you watch the video lecture, then you did. So you're able to answer this question. Actually, you know what? Let's answer it right now. How much energy is required to heat 35 grams of H2O to 20 from 25 degrees Celsius to 150 degrees Celsius? So we need two things from here, right? 35, we have 35 grams of water, right? And we're going from 25 degrees Celsius to 150. Let's go down a little bit here, right? We're going from 25. So this is gonna be 0 degrees. It's gonna be 100 degrees. So we're going from like somewhere right here, 25 degrees Celsius to 125, right? And so when we go from over here to all the way up here, we have to encounter phase change. And yeah, so when we go from phase changes, we have to calculate from, because we can't just use 4.18 or 2.02 as we did for water and steam. We have to go from 25 to 100 and then 100 to 150. And this is because water from 25 to 100, this is just water, right? Anything 100 degrees, from 0 degrees to 100 degrees is going to be liquid water. Liquid. And then anything from 100 degrees to 150 degrees is going to be steam, which is a gas. So we can't just use 150 minus 25 because that encompasses two phase changes. So we must go from 25 to 100, right? That's our first calculation using Q equals MC delta T. Then calculate the phase change from water to steam. And then we have to go from 100 to 150 steam. So there's three steps here. One, raise to 100 degrees Celsius. 2 is it's gonna be evaporation of phase change. And 3, it's gonna be raised to 150. Okay, cool. Just get rid of all of this. All right. Oh, we actually didn't need that. So our first like change is 125 to 100 degrees Celsius. So 25 to 100. So let's calculate that out. Right? We have Q equals MC delta T. Our uh our M is gonna be 35 degrees. Our C is gonna be water because remember we're still in that 0 to 100 range. Right? We're still dealing with 25 to 100. So it's still gonna be 4.18 because we're dealing with water. Temperature change is gonna be from whatever 25 to 100 is. So 100 minus 25 is gonna be 75 degrees Celsius. Hopefully I'm not going a little too fast here. So 35 times 4.18 times 75. Q is going to be 10,972.5. So for here, it's going to be 10,972.5. So now the phase change, right? And so for the phase change of water, it's a different story, right? We have to go from, let me see. Ooh. Where's the formula here? Hold on, I'll be right back. Okay, so basically it's just the mass times the enthalpy fusion, the heat of fusion change. I don't know what to say. It's up here. Yeah, molar heat of fusion. Or yeah. It's kind of embarrassing. But yeah. It's just HVAP or HCON. So the molar heat of or the grams for vaporization is going to be for water it's 334 joules to grams joules per grams. And then for vaporization it's going to be 2260. Please cooperate. All right, here we go. So it's going to give me mass, right? Grams times diffusion, or it's gonna be vaporization because we're trying to vaporize the water. So it's gonna be okay. So it's gonna be 35. Oops. All right, mass times and the enthalpy. So 35 times 2260 because we're trying to vaporize the water. This is gonna be well, equals to 78,100, and then to raise it to 150, right? We're still gonna use Q equals MC delta T. And so it's gonna be the M is gonna be 35 grams. C, since we're dealing with steam, we're gonna be using 2.02. So 2.02, and then for temperature change, it's gonna be 100 degrees to 150. So that temperature change is gonna be 50 degrees Celsius. It's gonna be 35 times 2.02 times 50. So Q will equal 35. And so 35 And so in order to find out the total amount of energy, we just add up all these numbers. 10,972.5 plus 79,100 plus 3535. You should get 93,607.5. Oh wait, no. I did something wrong. I did do something wrong. But no. Ooh, I did something wrong. I don't think anything wrong. Yeah, no. Fine. Fine. Um, okay, so like, yeah, I'm fine here. So it's just right here. One mistake here made. It's not kilojoules, it's joules. This is because it's uh I just used the wrong value. So just joules. Okay, next one. Energy involved in changing states. So let's get rid of this. I know we're at okay, yeah, we're fine. What is this number four? What is the significance of the horizontal portions of the graph? What is going on during those times? So when we talk about horizontal positions, talking about these these portions. And in those portions, we're dealing with phase changes here. Hold on. So right, we have we're dealing with phase changes here. So where is it? Where is it? Um right here. Here are the horizontal parts in the video lecture slides. So in these horizontal, we have melting and evaporation. In melting and evaporation, they're basically just phase changes. So and so they're phase changes, but what's going on, right? What's going on during those times? And so during phase changes, intermolecular forces are being broken apart. So let me just, okay, so right here. During all phase changes, instead of being used to excite the molecules to increase their kinetic energy, right? We're not increasing energy, right? Because we're staying stagnant. It's not going up, it's plateauing. So instead of being used to increase kinetic energy, heat energy is being used to directly break intermolecular forces, which enables a phase change. So I'm gonna just put down like heat is being used to break intermolecular forces, which enables a phase change. Okay, let's go. Number five, label temperatures on the scale. So you actually just know this by heart, but basically it's gonna be right here. The lower one's gonna be 0 degrees Celsius, and the upper one's gonna be 100 degrees Celsius. And this makes sense because this lower portion is melting, and for water to melt, it has to be 0 degrees Celsius, or to freeze as, or yeah, to melt, it has to pass 0 degrees Celsius, and then for it to evaporate. No, wait, what am I saying? For it to yeah, for it to melt, I'm sorry. For it to melt, it's to go past 0 degrees Celsius, and for it to evaporate, it has to go through 100 degrees Celsius right here. So 100 degrees and then 0 degrees. All right, number six. Does it require more energy to vaporize the water at the boiling point or to melt water at the melting point? Explain why. So, right, it's just saying that does it require more energy to go from to melt, which is here, or for it to evaporate, which is there? And notice, right? Notice how this line is longer. because it takes an incredible amount of energy, right? We're going from 100 kilojoules to 275. So it takes a lot more energy to evaporate than going from like this small little thing right here. So we can just put down um the line is longer. To vaporize water at boiling point. Okay, what's up? So number 7. Verify that it takes. Oh yeah, so we just did number 6. We're down to 7. Verify it takes 41,400. Oh no, I'm tripping. 4,140.7 joules of energy to heat 12.7 grams of water from room temperature to boiling point. Recall that the specific heat of water is 4.18. So right, we see joules. Well, we need to verify, which they just give me the answer, but we just need to verify it. So we're given grams, we're given a temperature change, and we're also given the specific heat of water. And just like I've been saying from the beginning, right? This is gonna this we're just gonna be using MCAT right here. Q equals MC delta T. So M is 12.7, C is 4.18, and the temperature change is from 22 degrees to 100 degrees. And so that, if you take 100, subtract it by 22, you're going to get 78. So it's going to be 127, or 12.7 times 4.18 times 78. And Q is going to be 4140.7 joules. 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 Yeah, just joules. Yeah. Right there, 4,400, 4,140. So this is verified. Given the fact that the how do you call this again? Thing for water. The enthalpy for vaporization of water is 2260 joules over grams. We know that 2260 joules of energy is required to vaporize 1 gram of water. To vaporize 2 grams of water, it requires 4,520. For 3 grams, it's so on and so forth. Verified takes 28,702 to vaporize 12.7 grams of water. So we have this rate right here, 2260 joules per 1 gram. So we need to vaporize 12.7 grams. Right, the table thing. What goes on the bottom has to cancel out. So that's be 1 gram over 2260, and on top is 2260. And then we just multiply both together. And then we get 28,702 joules. Verified. So number 9. Verify that it takes 1,513.6 joules of energy to heat 12.7 grams of steam from 100 degrees Celsius to 159 degrees Celsius. So, right, same thing. Q equals MC delta T. Our M is 12.7. Our C is 2.02. Temperature changes from 100 to 159. That temperature change is going to be 59 degrees. Plug and chug. Going to be 1513.586 joules. All right. Number 10, using your answers from 7 through 9, calculate how many joules energy it takes to change from 12.7 grams of water, 22 degrees Celsius, to steam at 159 degrees Celsius. So, all right, to find the total energy, we just add up everything. So we have 4140 plus 28,702 plus 1513. We should get 34,356.294 joules. So number 11, calculate how many joules it takes of energy required to change 32 grams of water at 35 degrees Celsius to steam at 100 degrees Celsius, at 120 degrees Celsius. We need to break this problem into 4 steps. So find the joules, it needed to heat the water to boiling point, right? So 35, boiling point at 100 degrees. So we need to go from 35 to 100. This temperature change is going to be 65 degrees. So Q equals mass is 32.9. C is 4.18 because we're in water range. And then the temperature is going to be 65 degrees Celsius. So 32.4 times 4.18 times 65. Q is going to be 8803. Oh, wait, no. What did I do wrong? Oh, wait, 32.9. Yeah, 89, 38.93. Joules takes to vaporize the water. So for vaporizing water, right? We're back up here. 2260 to vaporize. So we have it's just mass times HVAP. Mass is 32.9 times 32.9 grams over 2260 joules over 1 gram. Grams cancel out. Multiply this together, you get 2260 times 32.9, and we have 74,354 joules. So vaporize, find the joules needed for it to heat the vapor from boiling point to 120 degrees Celsius. From boiling point, that's 100 to 120. The temperature change is going to be 20 degrees Celsius. So still using Q equals MC delta T. We have Q equals 32.9. Steam is going to be 2.02. That's the specific heat energy. And then the temperature change is going to be 20 degrees Celsius. We have 32.9 times 2.02 times 20. And we have 12. um, hmm. Yeah. 2.0. Let me just see real quick. Get back. Yeah, I got it right. 32, 1329.16 joules. And so other steps from A, B, and C, right? We have 89, 38. 89, 38. Plus 74, 354 plus 13.9. Should get 84, 622.09 joules. So how much heat energy required to change temperature from 125 grams of ice from 32 degrees, 32.9, negative 32.9 to 75. So right. Oh, notice how in 11 we went from Q equals MC delta T to like this mass times vaporization back to Q equals MC delta T. So it's like you swap, you know, it's like you switch. So from when you go from negative 32.9, when you go from freezing, we need to find how much energy it takes to heat the water to melting point or heat the ice to melting point. So it's 32.9 to 0 degrees. This changes 32.9. So we have the first step is to do Q equals MC delta T. M is 125. C, our specific heat for ice will be 2.06. Temperature change is 32.9. So 125 plus 2.06 plus 32.9 should get 159.96. Second is to go from is to find the joules needed to melt to melt the water. Right? So it's going to be mass times H H fusion. Fusion is another word for melting. I don't know why it's called fusion. So mass is 32.9. The fusion to for melting is 334. 334, so 32.9 times 334 will equal 10,988. And then 3, you have to find how much it takes to raise from 0 degrees Celsius to 75 degrees Celsius. So from 0 to 75, that temperature change is going to be 75 degrees. So back to Q equals MC delta T. M is 32.0. Oops, I did something wrong here. Our mass back over here is 125. This won't be 10 something. This will be 41,000. Okay, back to Q equals MC delta T. Our mass is 125. C is 4.18. T is 75. Multiply all this together. 4.18 times 75. You should get 39.187. And then you add up all these together. You should get there's something wrong here. Oh, there's something wrong here. Okay, my bad. For this, I accidentally added them together. That's kind of embarrassing. Okay. Yeah, this shouldn't be 51594. This should be 8471. Right? So you add up all these together. 39 plus 41. There you go. Should get 89,406. 6 or 9. And it's somewhere near here. I got this. All right. That's it. Bye, guys.